don't know.
Maybe she just went to see the doctor.
I don't know. Karar seems to think this is possible, but I don't think so. We'll find out when we see her. Oh, sorry. We'll find out if we see her.
I know a lot of people deserted for that.
Really?
Yeah.
Really?
I swear, yes.
Maybe it's a Saudi thing.
Huh?
Maybe it's a North Saudi thing.
No, he's not.
I'm not sure.
Iraqi.
Iraqi.
Yeah? No, sorry, North Iraqi. Yes.
So,
You're North.
no, I'm south.
Oh, you're South. Okay. Totally wrong then.
So, no, I'm Kurdish.
North
So
or Kurdish.
Different culture, different language.
Okay, you're South Iraqi then. Alright, well then maybe it's a South Iraqi
Yeah,
thing.
maybe.
Okay. Could be. Okay, so last time, well not last time, but previously in maths class, we saw how to calculate things like this. If y equals x squared, what does dy dx equal? 2x. Yeah?
Yeah.
Suppose suppose I say dy dx equals 2x, then going backwards,
X is scared.
y equals x squared. So just a little bit of vocabulary.
No way around.
Yeah. Well, we'll get to all that in a moment, yes. This is called derivative. Well, that's the noun.
This integration.
And this is integration, which is the name of the lesson. So really, integration is the reverse process of finding the derivative. Although, as Tekken pointed out, there can be a small problem. So, for example, if you have y equals x squared plus 1, what's the derivative?
2x.
2x. 2x.
No, x?
2x.
It's the derivative.
Oh, yes.
So, going backwards, the answer should be x squared plus 1. But we said earlier, going backwards, the answer is just x squared. In other words, if you have x squared, it becomes 2x. If you have x squared plus 1, it becomes 2x. If you have x squared plus 2, it becomes 2x. So when you try to go backwards, you're not sure which one to go back to. So we say that the answer is x squared plus some constant. We don't know.
Because we don't know.
We don't know, yeah.
400, yeah.
So the symbol for integration is written like this. So this means integrate or anti-differentiate 2x. The answer is x squared plus c. And you can check the answer. The way to check the answer is the derivative here should be 2x, and it is 2x.
What do you call this?
Integration
Integration.
or antiderivative?
Antiderivative.
Yeah. Yeah. Well, antiderivative also, you know. Tecamel.
I used to call it.
Wait, I just used some Arabic here.
Arabic.
Tecamel.
Tecamel. Oh. Yeah, tecamel.
It's the opposite of mushtaka.
Yeah, exactly.
Yeah, exactly. Yeah. Yeah. Derivative. Yeah.
And you
Tecamel.
also, Mustafa.
Integration.
Mustafa also you call it.
Come in.
Come in. Yeah.
Ah, Yanni, why do you like? Ah, come on, Yanni, come on. What else are you saying?
Mustafa.
Yeah.
You call it sometimes kafala.
No, that's too much for me. I'll just stick with mushtaka. Thank you. Yes, yes. So in English we can say integration or anti-derivative. You know, like clockwise, anti-clockwise. You can say derivative, anti-derivative. You got the vocabulary?
Yeah.
Yeah? Okay. So let's have a look at some rules. So actually, I'll just give you the rules. So for example, we'll just do a table like last time. Yeah. So here is fx, and then here is its antiderivative. Okay? So the first one we'll do is xn, and its antiderivative is xn plus 1 over n plus 1 plus c. Likewise, if you had a constant, its antiderivative is constant x. And the reason for that is because it's like there's an x0 here, which becomes x1 over 1. I think some people have seen this before. Yeah. Okay, the second rule would... Oh, and a very important condition here. This rule is only true when n does not equal -1, because you have a big problem if you try to divide by 0. Okay, the second rule will do. If you have 1 over x, in fact, its antiderivative is log x. But you knew that already, kind of, because what's the derivative of log x? 1 over x. Therefore, the antiderivative of 1 over x is log x. Sin x will become minus cos x, and cos x will be sin x. One over cos squared x is tan x. Ekx is 1 over k ekx. And likewise, ex is ex. Did I leave anyone out? Sine, cos, we don't do tan yet. E log 1 over x. I think I got them all.
You're saying you will get this table in exam?
Yeah.
That's good.
6 of them, not all of them.
Not all of them. I don't. Only the ones I've numbered, I believe. I believe.
Number 7 is the same?
Ah, yeah. Number 7 is the same as 6, but just k is 1. Oh, yeah. Sorry. There's one more I remember. It's like number 2. So, in fact, what I'll do is... Rats. I'm going to... rats. I want to squeeze it in here. I'll just write it on the side, sorry. This goes with number 2. If you have 1 over ax plus b, it'll be 1 over b log ax plus b. Sorry, so really this is number 2, and then this goes with number 2. Sorry about that. 1 over b times log ax plus b. Sorry, not even b. Terrible. I didn't have any coffee yet today. This is 1 over a. Where's my pen? Hey. No, new teacher. Right. 1 over a. they're the rules. Can I go down? Amanda? Yeah? Okay. So let's have a look at some examples. What is the antiderivative of 14x plus 1? Well, if you want, you can change that into 14x power 1 plus 1. And the rule is you add 1 to the power and divide by the power. That's rule number 1, if you look back up here. You make the power bigger and then you divide by the power. Plus x plus c. Oh yeah, of course all of these here, I didn't write them in, but they all have a plus c. I'm not even sure if the plus c is in the formula book, but they all have a plus c. Okay, where was I? Yeah, here we are. And that's really it, that's the answer. Equals 7x squared plus x plus c. Let's do some more. Okay, can I go down? Another example? So let's say, for example, you want to calculate this 1 plus x squared dx. So what does the 1 become? X. This is like x power 1. So what will that become? X squared over 2. And then x squared becomes x cubed over 3 plus c. Okay, I want you to try this one for me. Make it a little bit tricky for you. Try this. See what you get. Let's have a look at it. Can I do it now? So the first thing you should do is change it into this. Now you can use your formula. You make the power bigger by 1, and then you divide by a half.
Why divide by half?
That's the new power.
No, divide by the new power.
Yeah. What did you think?
By 1.
Oh no, new power. So this is 2 square root x plus c. Yeah? Let me do another one.
You cannot do it with an logs.
Tell me why not. Does my log formula have a square root in it?
No.
So then I can't use it. Let's make one a little bit trickier. Try this for me. Actually, and that's, yeah. it's not. No, incorrect. Yep, can't do that. Not allowed. Forbidden. Any answers? So, just so you know, the answer is not this.
That's what they got.
Yep.
Is this?
And it's not this. Getting there, yeah, I think that's it.
That's right.
Well, I'm going to do it now. But it looks right. It's not that, because you can only use the rules when they're isolated, not when they're part of something bigger, like a fraction.
Or
Yeah.
when they don't have.
Yeah, they're only when they're isolated. So I can't, in fact, I can't do anything like this. I have to simplify first. So you probably spotted that the top is equal to this. And the bottom is this. This makes the problem a lot easier to do. Now you can use your rules because these are isolated. Oh, yeah. So that's x squared over 2 minus x plus c. Yeah, that's what I said, isn't it?
Well, what if it's not like easy as this?
No, it should be for semester 1. Semester 2. Yeah, that's a different story. But semester 1, it should be like this for the exam. It should always simplify to something that's easy to do. Always. Yeah?
That's crazy.
It sure is.
You know that?
I know that.
Okay.
Okay. Can I go down? Yep. So let me give you this one here. I tell you that the derivative is 4x plus 3, and I also tell you that f of 3 equals 29. So my question is, what does fx equal? I'll give you a couple of minutes to think about this. See what you can do. Oh, I think I told you this before, didn't I? But when I write this, it means derivative also. So this is the same as saying dy dx is equal to 4x plus 3. It's the same thing.
Yeah.
Alright, think about this for a minute, see what you can get. Yeah, 29. We are happy. Great. Yeah? Let's see how people are doing. I think it is, yes. Hey, I don't need help. It's a little tricky, this one. Let's do this one. Huh?
It's not that tricky.
Ah, it is. A little. So remember, when you have a function and you're going this way this is called the derivative.
C is equal to 2.
Yes? No. Just watch this, please.
Yes.
Yes? When we go this way, this is called the derivative. And when we go back this way, we call it antiderivative or integration. So here, I'm telling you that, I suppose you can think about it like this, that you have 4x plus 3 as the derivative. So if I want to go back to the original, the only way to go back is with integration, with antiderivative. So fx will be the antiderivative of 4x plus 3, which will be 4x squared over 2 plus 3x plus c. So that means fx is 2x squared plus 3x plus c. But I tell you f of 3 equals 29. So I can use that information to get the c, because then 29 should equal 2, 3 squared plus 3 times 2 plus c. So c should equal 2. So fx equals 2x squared plus 3x plus 2. And you can check the answer. You can check two ways. Check one. Does f of 3 equal 29? And the answer is yes. 3 squared is 9. 9 times 2 is 18. 18 plus 3 by 3 is 9. So 18 plus 9 is 27 plus 2 is 29. And the second check, does the derivative equal 4x plus 3? Yes, it does. So this is the answer. So remember, here to here is called derivative, and here to here is called antiderivative or integration. Okay, if you need to write this down, write it down. And let me just give you one more here to try. So try this one, please, for me. 1 over e2x. Got it, Tekken? Yeah. Okay, let's see what we can get. So here, this is the same as e minus 2x dx. And by using our rule, this is 1 over minus 2 e minus 2x plus c. So the answer is minus a half e minus 2x plus c, or if you want you can write it like this, minus 1 over 2e 2x plus c. Both are fine.
I'd like to think around the last answer.
That's okay, I suppose. Try not to do these things in the exam. I would like steps in the exam. Step by step.
Yeah.
If it's 3 marks, it should have 3 steps.
2 or 3 steps, yeah. Yeah. Yes? Yes. Yeah.
Anyway, gave us this table in exam.
And there you have it. Okay, let me tell you which questions I want you to do. So in number 1, I want you to do linear quadratic JKLN. JKLN. Got that?
Yeah.
In number 2, FGHIJ. Yeah, that's right.
CD.
That's it, just those 2.
Was 3, there's not 3.
I know, I don't need you to do question 3. That's right. You do more questions.